last set of notes in this unit are going to be very similar to the first two sections. We're going to be talking about graphing and what function notations are telling us to do to those graphs. So our parent function this time is f of x equals x squared, or y equals x squared, which is the parent function of our parabola. And if we don't already have a graph given and we need some points, all we have to do on any function is choose some values. So I'm going to choose -3 to 3. So -3 squared would give me 9, -2 squared, 4, -1 squared, 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And so now we have a table of values or some points that we can plot over here on our graph. So we've got -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And that gives me my parabola. Okay, so we're going to take that graph, this set of points, and we're going to make changes. So our first function that they're asking us to, function notation they're asking us to do is negative f of x. That should look familiar to you. That's negative y. So that means we're going to change the y values, and we know that when we change the y values, that should cause this graph to reflect across the x-axis. So if you'd like to write all those values out, you can. You certainly don't have to. If you're getting used to doing this, you may not need to. But we're going to change our y's. So the x's are staying the same. So this would be -9, -4, -1, 0, -1, -4, -9. So we have -3, -9, -2, -4, -1, -1, 0, 0, 1, -1, 2, -4, 3, -9. And all that did was take our graph and flip it over, just like it did when it was just a piecewise function graph. All right. So the next function notation, I call this opposite world. Anytime there is a value inside the parentheses with x, we actually are going to do the opposite of what it says. So when it says x minus 2, we're actually going to add 2 to the x values. So I'll make me a little table right here. So we're going to add 2. Let me see if I can pull this down so we can see the top there. We're going to add 2 to our x values. So -3 plus 2 would be -1. -2 plus 2 would be 0. -1 plus 2 would be 1. 0 plus 2 is 2. We probably see a pattern here. This is going to be 3, 4, and 5. All right, and then our y values are the same. 9, 4, 1, 0, 1, 4, and 9. So we're going to plot our points. We've got -1, 9, 0, 4, 1, 1, 2, 0, 3, 1, 4, 4, and 5, 9. So when we add 2 to the x values, this is going to shift the graph right 2. So Whatever it says inside the parentheses, we do the opposite. So if that's the case, on this next one, we're going to take our x values and we're going to subtract 2 from our x values. Okay, so we're subtracting 2. Let me see if I can pull this down just a little bit. So subtract 2. Negative 3 minus 2 would be negative 5. Negative 2 minus 2 is negative 4. Negative 1 minus 2 is negative 3, and so on. Negative 2, negative 1, 0, and 1. And our y values stay the same, so 9, 4, 1, 0, 1, 4, and 9. And probably if you want to think ahead, if here we added 2 to the x values and it shifted to the right 2, and here we're subtracting 2 from the x's, then it's probably going to shift it to the left 2. So let's go ahead and plot them. We've got negative 5, 9, negative 4, 4, 4, negative 3, 1, negative 2, 0, negative 1, 1, 0, 4, and 1, 9. And we can see that this notation, which meant to subtract 2, shifts our graph to the left 2. All right. So our next function notation is a little different. If you notice, this 2 is not inside with the x. F of x represents y, and this is saying y plus 2. And when it's outside of the parentheses, you do what it says. So this time we are going to add 2 to the y values. All right. So we're going to take our, let's see if I can put this on the side, our original values, which are right here, and we're going to add 2 to these y's. So the x's this time are staying the same, but we're going to add 2 to the y, so we have 11, 6, 3, 2, 3, 6, and 11. I'm going to add 2 to the y's. Okay, now some of these aren't going to fit exactly. I'll just put them off the graph just a little bit, but negative 3, 11 would be just above our graph. Negative 2, 6. Negative 1, 3. 0, 2. 1, 3. 2, 6. And 3, 11. So we can see that that shifted our graph up 2. All right. So if this notation was a change in y, then this would also be a change in y. We're going to do what it says. It says y minus 2, so we're going to subtract 2 from the y values. So our x's are just like the originals again. But our y values this time, so here's our original y values, we're going to subtract 2. So 9 minus 2 is 7, 4 minus 2, 2, 1 minus 2, negative 1, 0 minus 2, negative 2. Then we have a repeat here, 1 minus 2, negative 1, and 2, and 7. All right, so this graph, if this one went up 2, this one should be going down 2, but let's go ahead and plot. We're going to have negative 3, 7, negative 2, 2, negative 1, negative 1, 0, negative 2, 1, negative 1, 2, 2, and 3, 7. So it did take the original graph and shift it down 2. So let's recap for a minute. These two graphs where the value was outside of the parentheses made a change in y, and they're going to shift the graphs up and down. These graphs, the value was inside with x, so it made a change to the x's and it shifted the graphs left or right. Okay, so the notations for the functions on the back. Also, if the value is outside, then we do what it says. This would be 2 times f of x, or 2 times the y values. So we're going to take the original y values and we're going to double them. So here's the original values. The x's are going to stay the same. And the y values are going to double. So 9 times 2 is 18. 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. And then we repeat those 2, 8, and 18. All right, so obviously 18 is way too large for our graph. So we're going to just use these values right here, down to the 8. So we're going to graph negative 2, 8, negative 1, 2, 0, 0, 1, 2, and 2, 8. And as you can tell, that made that graph a lot more narrow. But what we need to think about is what happened here. We multiplied the y values by 2. The y values run up and down, and what it did was pull those values up. This one was at negative 1, 1. Now it's at negative 1, 2. This was at negative 2, 4. Now it's at negative 2, 8. So what it actually did was stretch the y values by 2. And then this was a stretch that goes up and down, or vertically. So it's a vertical stretch. All right, so same thing here. It's on the outside. It's going to change our y values. So our x values are going to stay the same. But our y values, so here's the original ones. Our y values are going to be cut in half. So 1/2 times 9, or 9 divided by 2. 4 divided by 2. 1 divided by 2. 0 divided by 2, still 0. And then we repeat those values. All right. So these are the values we want to plot this time. So we've got negative 3, 4.5, negative 2, 2, negative 1.5, 0, 0, 1.5, 2, 2, and 3, 4.5. And what that did was make our graph look a little bit wider. And it does look wider, but remember that what changed here were the y values. And what we did to those y values was bring them down. It used to be that this was -3.9. We brought it down half of what it was. So this is actually a shrink. We are shrinking the y values. And so it's called a vertical shrink. All right, these next two graphs, we're back inside the parentheses with x. So remember, that's opposite world. Everything's the opposite of what it looks like. And it looks like it says that we want to multiply x times 2. So we're actually going to do the opposite of that. We're going to divide the x values by 2. Now that's the same as multiplying by a half. So if you want to think of it as multiplying by a half, you could. So this is a change to our x's. So we're going to take these values, we're going to divide them in half. So -3 divided by 2. -3 halves are -1.5. -2 divided by 2, -1. -1 divided by 2, -0.5. 0 divided by 2 is 0. And then we have +0.5, +1, and +1.5. And our y values stay as the original ones. All right, so let's take a look at this one. We have -1.59, -1, 4, -0.51, 0, 0, 0.51, 1, 4, 1.59. So we thought that one up there was skinny, but this one's really, really narrow. But this time it was the x's that changed, and the x values run horizontally. So this is called a horizontal shrink. We kind of squished it in like an accordion, just pulled it in. So a horizontal shrink. All right, so on this last one, it says that we want to multiply the x's by a half. So we're actually going to do the opposite of that, which is to multiply the x values by 2. So here's my x values. I'm going to multiply those by 2. So I have -6, -4, -2, 0, 2, 4, 6. And the y values, they're going to stay the same. So multiply the x's by 2. It's the opposite of dividing by 2 or multiplying by half. And so let's see what we get here. We have -6, 9, -4, 4, -2, 1, 0, 0, 2, 1, 4, 4, and 6, 9. And that one got a whole lot wider. So what we did there, again, was a change to the x's. So it's a horizontal change, and it pulled it out. So this is called a horizontal stretch. All right, the last piece of this, what we want to be able to do here is figure out where the graph has moved, what all has happened to this graph, and then we're going to talk about what the equation might look like for that. So in this graph, remember that the original parabola starts at the origin and is up this way. So it looks like if the vertex was at the origin, we've moved that to the right 5, and we've gone up 1, 2, 3, and it's also been reflected because it's flipped upside down. So if we wanted to try to make this happen in the equation, y equals x squared, then to reflect it, we want to make it negative. To go up 3, we want to do a plus 3. And to go right 5, we would do the opposite of what right or positive would be, and we're going to put minus 5 in the equation. So here's what it would look like. We're going to have y equals negative in front of our function, and then in parentheses with x, we're going to have minus 5. Name the function, it's the parent function squared, plus 3. Now this is the equation of that graph. The function notation, like this kind of notation for what just happened right here, would look like this. We would say we want to make it negative of f of x, but it's not just an f of x, it's x minus 5 because we shifted it right, plus 3. So this is the function notation. And this is the actual equation of this graph.